Hello everyone, welcome to our channel AskPrep. In today's series on 11th grade chemistry, we will be studying chapter 9, hydrogen, in detail. Let's start the video. Start with electronic configuration of hydrogen 1s1. Position of hydrogen in the periodic table. The position of hydrogen in the periodic table is not fully justified because it resembles both alkali metals and halogens. Next is resemblance of hydrogen with alkali metals. Electronic configuration. Hydrogen has one electron in its valence shell similar to alkali metals. Formation of unipositive ions. Both hydrogen and alkali metals form unipositive ions. For example, sodium, sodium plus 1 electron, hydrogen, hydrogen plus 1 electron. Oxidation, state, hydrogen and alkali metals both show a +1. Oxidation state. Reducing agents. Hydrogen, like other alkali metals, acts as a reducing agent. Affinity for electronegative elements. Both hydrogen and alkali metals form compounds with electronegative elements. Examples: sodium oxide, sodium chloride, H2O, HCl. Isotopes of hydrogen. Hydrogen has 3 isotopes: protium, deuterium, and tritium. Preparation of dihydrogen, H2. Laboratory, preparation of dihydrogen. It is prepared by the reaction of granulated zinc with dilute HCl. Zinc plus 2, HCl equals zinc chloride, 2 plus hydrogen 2. It is also prepared by the reaction of zinc with aqueous alkali. Properties of dihydrogen. First is physical properties. Dihydrogen is a colorless, odorless, and tasteless gas. It is a combustible gas. It is insoluble in water. It is lighter than air. Chemical properties. Reaction with halogens. It reacts with halogens, X2, to give hydrogen halides, HX. Hydrides. Hydrides are classified into 3 types: ionic or saline or salt-like hydrides, covalent or molecular hydrides, and metallic or non-stoichiometric hydrides. First is ionic or saline hydrides. Hydrides formed between hydrogen and electropositive elements of group 1 and 2, S block, are called ionic or saline hydrides. Properties of saline or ionic hydrides. The hydrides of lighter elements like lithium, beryllium, and magnesium have significant covalent character. Ionic hydrides are crystalline, non-volatile, and non-conducting in the solid state. They conduct electricity in the molten state and liberate hydrogen at the anode. Second is covalent or molecular hydrides. These are binary compounds of hydrogen with non-metals belonging to the p block. Examples: NH3, CH4, H2O, HF. They are mostly volatile compounds with low boiling points. Types of molecular hydrides. First is electron-deficient molecular hydrides. Hydrides in which the central atom does not have an octet. Example: BH3, MgH2, BeH2. Second is electron-precise hydrides. Hydrides in which the central atom has its octet complete. Example: group 14 hydrides. They have a tetrahedral geometry. Third is electron-rich hydrides. Hydrides that contain lone pairs of electrons. Example: NH3, PH3, H2O, H2S. NH3 and PH3 have one lone pair, while H2O and H2S have 2 lone pairs of electrons. Metallic or non-stoichiometric hydrides. These hydrides are also known as interstitial hydrides. Transition metals from groups 3, 4, and 5 form metallic hydrides. In group 6, only chromium forms chromium hydride. Metals from group 7, 8, and 9 do not form hydrides, a phenomenon called the hydride gap. Recent studies show that only nickel, palladium, cerium, and acetyl are interstitial in nature, meaning they can occupy hydrogen atoms in interstitial sites. These hydrides are generally non-stoichiometric, with compositions varying with temperature and pressure. These hydrides have a metallic appearance and their properties are closely related to those of the parent metal. They are strong reducing agents, primarily due to the presence of free hydrogen atoms in the metal lattice. Next is water. The human body contains about 65% water, while some plants have nearly 95%. Physical properties of water. The freezing point of water is 273.15 Kelvin and the boiling point is 373.15 Kelvin. Water has a maximum density of 1 gram per cubic centimeter at 4 degrees Celsius. Water is a colorless and tasteless liquid. Due to hydrogen bonding with polar molecules, even covalent compounds like alcohols and carbohydrates dissolve in water. Types of hardness of water. Temporary hardness. Temporary hardness is caused by the presence of bicarbonates of calcium and magnesium. It can be easily removed by boiling. Permanent hardness. Permanent hardness is due to the presence of chlorides and sulfates of calcium and magnesium. It cannot be removed by boiling but can be eliminated through chemical methods. Soft water? Water that readily forms lather with soap is called soft water. Example: rainwater, distilled water. Hydrogen peroxide, H2O2. Uses of H2O2. It is used as a mild disinfectant and is marketed as perhydrol, an antiseptic. It is used in the manufacture of high-quality detergents. It is used in the synthesis of hydroquinone, tartaric acid, certain food products, and pharmaceuticals.
Hydrogen as a fuel. The basic principle of the hydrogen economy is the transportation and storage of energy in the form of liquid or gaseous dihydrogen. The advantage is that energy is transmitted in the form of dihydrogen and not as electric power. Advantages as a fuel: it is used in fuel cells for generating electric power. The combustion of hydrogen produces minimal pollution, with no emission of unburned carbon particles as smoke. Dihydrogen releases more energy upon combustion than other commonly used fuels, both in its gaseous and liquefied forms. 5% of dihydrogen is mixed with CNG for use in four-wheeler vehicles. Thank you for watching. We will be dropping notes in the description of this video. If you found this video helpful, kindly like, subscribe, and share. See you in the next video. All the best for your exams.